you can go ahead and get started.
Hi, everyone. Welcome to my presentation on unit testing for raw programs. I'm Henry Scheibel. I'm a student and captain on Team 2239, the Technocrats, which is from Hopkins High School. This is my third year on the team. Today, I'm first going to talk about what build framework and libraries I used for the code examples in this presentation, so you can replicate them if you want to. And then I'll talk about an introduction to unit testing, go over what unit testing is, talk through a simple example, and then talk about the purpose of unit testing. And then I'll go through a really important feature of unit testing, especially in FRC, which is using mock objects. And we'll expand the previous example to use those. And then we'll go over a few examples of how you can write unit tests for an FRC program. And then we'll have time for questions at the end. Also, if you have any questions during the presentation, feel free to put them in the chat or interrupt me, and I'll also pause periodically. So for the all the examples in this presentation, I'm using Java with Gradle, and two libraries I'm using are JUnit and Mockito for the tests. If you want to include these libraries in your own FRC programs, if they use Java, you can access the build.gradle file and add these two lines. And this presentation will be available if you want to look at these two lines later. Okay. So first, we're going to talk about an introduction to unit testing. Unit tests are automated programs that test your software. Usually you run them at compile time, and it tells you whether the functions and other aspects of your program are doing what you want them to do. And each unit test will focus on exactly one function and tell you whether it's working or not. You can also think of unit tests as writing a specification for what small parts of your code are supposed to do. Generally, when you write a unit test, you break it down into three components, and these are often called arrange, act, and assert. In the arrange step, you set up the testing environment, you create any variables you need. You will often have to instantiate classes during this step and make some objects. And then the second step is act. During act, you are just performing the action that is being tested. Usually, unit tests test one function, so the act step will just be calling that function. And then finally, for the third step, it's called assert. And in this step, you check that the output from the function is what you want it to be. And if it is what you want it to be, the test will pass. And if it wasn't what you wanted, the test will fail. So let's look at an example of this. So can you guys all see my VSCode window?
Yes, we can see it.
Okay, thank you. So this is a fairly basic example of a unit test. And this app class is actually taken directly from the template that Gradle produces for you whenever you make a new Java project. This class has two functions. One of them is the main function. So this will run when your program starts, and it instantiates a new object of the class and calls the getGreeting function on it, and then prints the output of that function. So in this case, it would just print hello world, because the getGreeting function returns hello world. So this is a very simple unit test that can be run on this function. All unit tests are a function inside of a class, and to tell Java and tell JUnit, which is our unit test library, that they need to be run as a unit test, you put the @test decorator before the function. So this test is called test app has a greeting, and basically it passes if the getGreeting function returns any string, and it fails if the getGreeting function returns null. So let's first look at our arrange step. We make a new instance of the app class, and we assign it to a variable called class under test. We'll need this to call the function, which we do in our act which we do in our act step. So here we call the function we're trying to test, and we put its output in a string variable called output. And then finally, in the assert test, in the insert step, we use a special Java keyword called assert, which will evaluate a Boolean expression like this one and throw an error if it's false. So in this case, if output is not equal to null, which is what we want, then the test will pass. However, if output is equal to null, which means get greeting returned null, then the test will fail. Does anyone have questions about this?
And guys, you can go ahead and unmute yourself or just use the chat if you don't want to speak.
Okay, if you come up with a question later, let me know and I can come back to it. So now we are going to talk about some advantages of unit testing. So one of the main advantages of unit testing is that any errors will appear earlier in the development cycle. For example, in the example we just looked at, if the get greeting function had returned null, we wouldn't have gotten any compile time errors for that, but it might have caused something really weird to happen once we've started running our app and we've started giving it to users. This is not ideal because if you get a compile time error, you can fix it quickly and it won't ever impact anyone's experience. But runtime errors are often much harder to debug and fix. Writing a unit test also forces a programmer to think more carefully about their code. I think this will become more apparent later in the presentation. But if you can write a function that's easy to unit test, that function is often written a lot more elegantly and has less side effects, which we'll also talk about later in the presentation. Kind of related to that is that it encourages isolation and modularity. So functions are easier to unit test when you break them down into small chunks. So each function does a smaller bit of the program instead of having very large functions that are really complicated and do a lot of different things. Any questions on this? Okay. The next thing that we are going to talk about is mock objects. So mock objects are a very important part of unit testing, and we're going to continue the previous example to see how we could add in a mock object. So let's say, going along with the previous example, instead of just returning hello world every time for the function get greeting, we want to use a class greeting generator to generate a greeting. And I'll show you what this looks like in 1 second. Okay, so here you can see that I've changed the app class a little bit. It now has a constructor that accepts an instance of greeting generator. And I also just changed this line because it has to use the new constructor. So let's look at what the greeting generator class looks like. So greeting generator, it's very simple. It just has one function, public string get greeting, and right now it returns null. So let's look at how we can write this functionality that we want into our test. You'll notice now that right now, this is not doing what I said we wanted it to do. It's not using the greeting generator, but we'll fix that in a moment. Let's look at the test for now. So our arrange step is a bit more complicated because we have to make a mock object. So we're making a mock greeting generator, which is of type greeting generator. And instead of using a new greeting generator, we're using mock greeting generator class. And this is a function from the Mockito library that I talked about before. So what a mock is an object. And to all the other objects, it's going to look like it has type greeting generator. But it has a few special things that we can do with it. One of them is that it kind of records a history of what was done to it. So if functions were called on it, we can inspect it later and see what happened. We can also override certain functions to make it return what we want it to return. And it actually doesn't use any of the code from greeting generator, just the method signatures. And then just like last time, we make a new app and we call it class under test. And this app will take the mock greeting generator as a constructor parameter, just like we defined over here. And then in the act step, it's very similar to last time. We're calling the function we want to test. And then the assert step is very different. And this is unique to how mocks work. This line, the syntax kind of said that it verifies that we called the get greeting function on mock greeting generator. And I think this will become clear in a moment. But right now, if we run the code, the test should fail. So let's see what kind of error message we get from this. So it's running the tests and the build failed. As we can see, it failed because of the test step. And let's look up here. So here, this is what an error message will look like if one of your unit tests fails. It gives us the name of the test right here. That's just the name of the function, just like that. And then we get exception from Makito saying wanted but not invoked at app test on line 20. So if we look at line 20, that's our verify line. So it's basically saying that we wanted this function to be invoked, but it wasn't. So the test failed. Now let's see how we can change app to make the test work. So what we want to do here is return greeting generator dot get greeting, because now we're using the greeting generator, and now that we've called this function on it, this verify will succeed. However, to get the greeting generator, we also have to change the rest of it a little bit, and I am just going to switch quickly to the final code. Okay, one moment. Okay, there we go. So here's our final code. We've made an instance variable called greeting generator, and we've set the constructor argument to that instance variable. And now in get greeting, we use that. So now if we build the code again, we should see that the test passes. Okay, so I see we have a question about what does mocking greeting generator do? So when you mock a class, the difference is that it's not using any of the code from greeting generator. The only thing it looks at is the type, which is basically what functions does greeting generator have, what parameters, and what do they return. So you can call any of these functions that greeting generator has. Right now we only have one, but they won't do anything. It won't use any of the code inside of them. And also we can do special things like this, like look at the history of how it was interacted with. We'll actually,
thank you.
Okay. We'll also get into another feature of mocking in one of the FRC examples that I think will also make it more clear. Okay, another subtlety of this test that I wanted to point out is that we're not actually testing whether we return this. We're just testing whether this function was called at all. So the test could still pass if we just returned literally anything as long as we called it. Oh, I did not have that copied and pasted. But as long as we called it somewhere in the function. So the test will still pass, but that's obviously not the behavior we want. So this is an indication that we probably need to write our test a little bit better or write a different test to cover this kind of behavior. So now, does anyone have any questions on that?
Yeah, so to tack on to what Henry's saying, right, by using mock here, he's able to test this portion of the code. So he's not testing the greeting generator itself at all. This test only focuses on his app portion, right? So he can break apart his tests so that the tests don't have to test everything that builds up to that point in the code.
Yeah, so Jason's getting at my first point here, which is that they allow you to test one class at a time. As I was saying, because we're mocking greeting generator and we're not instantiating it, none of the code from greeting generator is being used. So that means how we write greeting generator has no impact on whether the test passes or not. And that's exactly what we want. Because like I said earlier, unit tests should only test one thing. And in this case, we're only testing the function get greeting. And however we write other functions, however we write greeting generator, it shouldn't matter. We can write our own tests. We can write different tests for greeting generator. And this way, whenever certain tests fails, you know that the problem has to be isolated to a certain function, and then you can go to that function to debug it. So some other benefit of mocks is that you can monitor the side effects of a function. So really a side effect is anything that happens in a function that isn't returned. For example, this is basically a side effect because we're calling this, and it has nothing to do with what the return value is, but it does, it could theoretically change something about greeting generator. And we can monitor that using the verified here. When it comes to FRC, the another big advantage of mocks is that you can test code that directly interacts with hardware classes like Talon SRX or like a solenoid or something, like from the WPI lib or CTRE libraries, without running the code on the RoboRio, because we can just mock those classes. So like you don't have to somehow figure out a way to attach a motor to your computer. We can mock that and see that the code does what we want it to do. Any questions about that? Okay, in that case, I can start talking about how we apply this to FRC. So I'm just gonna open a different folder here. One moment. Okay. Okay, so I'm opening up a new folder here, and we're going to take a look at how you would write a unit test for a command in a command-based Java FRC program. So here is a command we use. Oh, here's a command we wrote last year that causes the drivetrain to drive along a motion profile. And if you don't know what that is, it's not a big deal. The important thing is that this is just a command. And let's look at how we could unit test it. So here's the unit test. Oh, sorry, 1 second. Okay. So the first that's different here that you may have noticed is that we have a before function. So in all of these unit tests, the arrange step, except for this one, in all these unit tests, the arrange step is basically the same. So we can put it in a different function. And if we decorate it with the before decorator, JUnit will run it before it runs any of the functions decorated with test. So in most of these, we have a subsystem and we have the command. And the subsystem is a mock. It's the mock of our class representing the drivetrain. And then to instantiate the command, we pass the drivetrain. And the other, I'm not going to get into the other arguments here, but they don't really matter that much for what we're talking about. And then, for example, if we're testing the initialize in the act step, we run that command, and then we want to double check that it called these 4 commands on subsystem. And if it didn't call any of these 4, the test will fail. Does anyone have questions about that? Okay, another new aspect of mocks that we used here is this test. Test is finished true. So this is a new thing that we can do with mocks, which overrides how their functions work. So we're saying when someone calls this function on subsystem, then return true. So it doesn't actually matter how we wrote this function at all. The mock is always going to return true because that's what we told it to do. So then we can double check that when we call command.isFinished, which is right here, it's calling this function, and the return value is the same as what we told this to return. And then we're asserting that these 2 things are equal. So we're basically saying we want command.isFinished to be true because we know that the function we want command.isFinished to be calling will return true. And then we can do the same thing for false. Any questions about that? Okay, then I want to talk a little bit about how we can often test different layers of our code. So if you use a command-based framework, you'll generally have your code in 3 layers: commands, subsystems, and components. And some teams may have more, but if you use a command base, this is kind of the minimum. So when I say components, by the way, I mean any class that represents hardware. Usually these are taken from libraries, like WPILib has a lot for solenoids and that kind of thing. You can get like talons from the CTRE library and that kind of stuff. So that's what I mean by component. So at the top, our commands use subsystems as their constructor arguments, because the commands will always work by calling specific functions on subsystems at times. So then whenever we write a unit test for the command, we will create mock subsystems to use in that unit test to make sure that we're only testing the command regardless of whether the subsystem works or not. And then we can do the same thing for subsystems. If we want to test the subsystems will all take components as their constructor arguments, because their functions will work by calling different functions on the components. So then we mock the components to make sure that the subsystems work how we want them to, regardless of whether the components work or not. And then the components we generally won't write unit tests for because we didn't write the classes. We're taking them from libraries. But the important point here is that the unit tests for commands and subsystems, the only thing that should determine whether they pass or fail is whether the commands work or whether the subsystems work. They shouldn't cross over at all. We should never have a command unit test fail because we wrote the subsystem badly. And writing good unit tests to make sure everything is isolated is not always easy, but it's a really important skill to develop. Anyone have questions about this? Okay, so now we are going to look at one more example that relates to FRC. So one thing that some people may be thinking right now is that a lot of these functions are only like one line. Why would you ever write a unit test for a one-line function? Obviously, it's going to do what you want it to do. That point may be valid. I'm choosing a lot of simple functions so far to use as examples because they're simple and the unit test can work simply. So now let's look at a more complicated function that I think is more plausible, that it's pretty easy to write wrong. And that's why it's good to write a unit test for it. So one moment. So this class that I have on the left here is called motion profile, and we used it on our robot last year to basically represent any motion profiles that we wanted to run. But the big deal is this function, which converts the motion profile from one format to another. We read it out of an XML file using a library that will produce it in one format, and then eventually we have to convert it to a format that we can pass to the talons to run. So the get buffer trajectory point stream, because the buffer trajectory point stream is the format the talon recognize, will convert our current motion profile to a motion profile in the talon format. So you can see this function is kind of confusing, and you may not really know where to start if you're writing it for the first time. This is a case where it's much better to write a unit test first. So here is our unit test for the function. Because in the unit test, instead of trying to figure out a way to convert any motion profile from one format to another, we can just give it an example. So here, we're basically constructing a trajectory, which is the first format that we're converting from. And you can see I'm actually just putting in real numbers here because we're putting in an example. And then we construct what we expect the converted output to be. I'm not going to get into how all of these functions work, but basically we're building up a buffer trajectory point stream, and we're building up a trajectory that should be convertible between one another. And then we make sure, using our act and assert, that when we call the get buffer trajectory point stream, the actual is what was expected. And again, this class also uses the before function. Basically, this function is just called before this function. There's not much difference than if they were all together. Any questions about this example? Okay. If you think of one later, feel free to let me know and I can come back to it. Now I'm just gonna tell you guys how you can access the code from this presentation if you want to look at it more in depth. So the first two examples I use using like the app and the greeting generator can be found in this repository called unit test demo. And then all the examples that have to do with FRC are taken directly from our competition code repository last year. And also, if you want to look at this presentation again, you can find it on our technocrats2239.org website under resources presentation jumpstart. And I can put that link in the chat. Okay, any questions?
Thanks for sharing, Henry. That was really interesting. I have like a million of questions. So you have to spend the entire weekend to explain it, everything all over to me. So I won't ask any, but we're looking forward to more questions coming to the chat, or guys, you can go ahead and unmute yourself then and use this opportunity while Henry is here. He can answer all your questions.
So
Yeah,
in FRC,
go ahead if you're ready.
okay, sure. So in an FRC setting, in your unit test, what is the most common thing that you're asserting? Are you normally asserting return values, or are you normally asserting whether methods were called with verify?
So in subsystems and commands, it's almost all verify, because usually those methods don't return anything, they just do things. But in like, if you're writing like helper classes that aren't necessarily like a command or a method, like the motion profile class I was just showing, those are going to mainly be assertions because they're returning things and you don't really care what the method does as long as it returns the correct value.
All right, thank you.
Yeah, and from mine, I was just, maybe you could go back to reiterate the when operation that the mock provides and how you're using that in the case of the is finished.
Sure. Okay. Actually, this should be here. There we go. So this is the when operation. So basically, it's modifying how this mock works. So this goes back to what I was saying earlier, which is that mocks don't actually use any code from the class. They just use the structure of the class, like what methods it has, the return types of those methods, the arguments of those methods. So we can define what a function does. So this is basically like if we were inside the class and we wrote like the is like the Boolean is motion profile finished, and we just said return true. This is basically a shortcut way of doing that because it's a mock. And then how this test works is that we want the command.isFinished to call this method and return the same result as it. So now we just want to assert that these two things are equal, and the test will fail if those two things aren't equal. Does that answer your question?
Yep. Okay, I think it does. In that case, it's the way I sometimes I've stubs where you just say I have a different object, a class for test of the same type, where you can insert your own functionality into the methods that are called. This is a shorthand way of kind of doing that with the mock itself. Is that true?
Yeah, for really simple functionality, like we just
Yep.
want it to return the same thing all the time. This is usually the simplest way to do it. Yeah.
Okay.
Can you add more like complex functionality with the when method, or would you need to do something else?
You definitely can, and I think that was what Brian was talking about, using stubs. I'm not an expert in that, but if you look up the Mockito documentation, they have a lot of tutorials on how to do more advanced things. Anything using mocks in this is all taken from the Mockito library.
All right, thanks.
I was going to ask, I'm curious if any other teams have used unit testing at all. I'm not sure. I think we have a couple other teams in here.
I would say it's a goal, but we haven't achieved it.
Yeah, we also we definitely have not written a unit test for every part of the code. We've written a unit test for a small minority of the code, but we're working on building that and writing more and more as a future. I guess that's a kind of a note for teams. Like, you don't have to go all in the first time you do it and write a unit test for every single thing. You can try it out for a few small things, and if you think it's helpful, you can keep building on that.
Just curious if you've done anything or in timing of how you've written your tests relative to the code. Have you done everything kind of like test first or test driven, where you write the unit test given what you expect it to do before you write much or any of the actual code, and then you can see that it fails because you don't have any code supporting it, and then you write the code to make those tests pass. It's a little bit out of order, but it's another method of kind of using your test as defining what you want your code to do.
I would say that's always the goal. It doesn't always happen exactly that way, but yeah, that does happen a lot for us, and that's always our goal.
Excellent. That's a very good way of trying to progress, because then you know exactly what you've written satisfies what you intended it to do and doesn't have side effects. So.
Henry, do we usually have the same person write the unit test and the code? Or do we ever mix it up and have some people write the unit test?
Important point. I knew I was going to say something about that, and I just forgot about it. But yeah, unit tests can also be a really good teaching tool, because you can have a more experienced member of the team write the unit tests, and then have a newer member of the team write the code to try to satisfy those unit tests. And it can often help new members of the teams learn to program faster. And then eventually you can teach the new members of the team how to write both the unit tests and the code. But yeah, it's often useful to have different people write them. One other thing that I realized I may have forgot to mention is that whenever I was building the code in the FRC examples, that was all like exactly the same thing as like pressing the WPIlib button in VSCode and then hitting the build robot code button. Unit tests are automatically run by Gradle, which is what WPIlib uses whenever you build your robot code. So you really don't have to do anything special to run them.
That's a good point. I missed that part. If you mentioned anything earlier on about how you connect it to the build automatically, is it just the fact that you have classes defined that are of the JUnit?
Yeah, so I'll get into that quick. So the first thing you need to do is add the libraries. So in build.gradle, if you add libraries as testa implementation, you don't even have to download them. It'll download them for you when it builds, and it'll cache them for use in the future. but I can show you how you like where you put the unit tests regarding other things. One moment. Okay. So I'm gonna this is what a normal. Oh, there's a lot of folders open right now. This is what a normal I would say FRC structure would look like. So you have your source folder, and then inside source you have main and test, and then below those the directory should look very similar. So like for example, if something I'm testing is in main Java robot commands, then its test should be in test Java robot commands. And then you just have to make sure that before every function you put this test decorator, and then it'll know to run them.
Terrific.
Does
So
these
then
tests also? Go ahead.
Go ahead. I was going to say, yeah. So then there's nothing else like in a config on Gradle or wherever that you have to specify which ones you do or do not want to run during the build, or is it by default all of them?
I'm sure there is a way to like stop certain one of them from running, but it, in my experience, the default WPI-lib configuration when you just make a new template product is that it will run all of them whenever you build.
Excellent.
And you may not always know that. A good way to double check is run the Gradle build with a info flag, because if they pass, usually it will just print absolutely nothing. So that if you want to double check that they're actually being run, if you do the info flag, you'll see that there's a task test that succeeded, and that then you know that they're being run.
I don't know about Visual Studio Code, but on my team we mostly use IntelliJ. And yeah, I don't know about Gradle through the command line, whether that allows you to select it, but in IntelliJ, you through the GUI, you can select a code, select a single test to run by itself. It'll have a run button next to each of your test methods, so you can just run one or two if you want.
VSCode theoretically has an extension that's supposed to do that, but I've never really gotten to work. But yeah, I also do use IntelliJ sometimes, and yeah, it's really easy to run tests in there because like the buttons pop up in the code. That's a good point. Another extension of this that's not really that important, but it's just useful, is that if you are using GitHub, which I assume many of you are, to host your code, you can create a workflow in GitHub Actions that's really simple. It's actually just the default Java project with Gradle workflow, which you can search up in the extensions like marketplace on GitHub. And then every time you push your code, it'll automatically build your code in the cloud, and you can see which commits passed the unit test and which didn't in GitHub, or which built, I guess, too. And that's really useful to like make sure if you want to use a specific version, it should be one that passed that workflow.
And in that case, does the push get rejected if the tests don't pass? Or I'm assuming you can set that up.
You could definitely set it up that way. By default, no. Like GitHub Actions you can make them as pretty much as complicated as you want. But I think the simplest way to start is just by using the default Java with Gradle template, and that does not reject the push. You can just tell whether a certain commit passed or not.
So I guess that setup that you're showing that at before, that's like a test fixture, if you will, setting up an environment for testing. Is that correct? Like some environment variables and things like that, or objects initialization. And is there any like tear down step as well, which is available here in this?
I guess the teardown step, I don't usually write a teardown step because most of these tests I feel like aren't usually ever accessing something related to hardware or IO that could be damaged. So just having it be garbage collected works, but that is something to keep in mind, I think. Yeah, like if you're accessing any sort of hardware, like a motor or something, that would always be mocked. Tests run on the computer, not the robot.
Okay.
And in other ones, I guess I've seen So the before is before each of the tests, correct? It kind of resets up and runs before each of those test methods. Yep. Is there a overall, like as Apoorv was saying, a fixture type setup that's a one-time?
Yeah, I think that's the before all decorator.
Okay. Yeah. Then I would guess.
I'm not 100% sure about that, but I think there's a lot more decorators than I've gone through, and those can all be found in the JUnit documentation. So I know that might be a little bit confusing, but everything's kind of two different libraries here. Anything that just has to do with the test is JUnit, and anything that has to do with mocks like verify and when and then return and just like the mock function is all coming from Mockito. So like also some of the asserts are coming from JUnit too, if they're a function, not the keyword.
So just so that I am clear, like, did you mention that you could actually simulate motors and stuff using the when, or did I misunderstand it? So if instead of trying to connect to actual motor and test it, we could use some of these for, let's say, testing a motion profile if it's really going the way we have coded it. So is that, you said using that is motion profile finished, or did I misunderstand?
I would say that in general, simulate might be a little bit of a strong word. It's really not like, I would say unit testing is not the right solution if you want to like do something complicated, like run a motion profile in your motors and like have it draw the path that it thinks your robot would go. It's more that like you're testing that it interacts with the motor in the right way, that it's calling the correct functions on the motor, but you're generally not like checking more complicated things like the motors are turning exactly the way you want them to go and the robot is going to go in the right direction and that kind of thing.
Got it. Just out of curiosity, have you guys tried something which does help with that kind of capability where you could simulate?
I guess one thing that some FRC teams use that has that is synthesis. We haven't used it a ton. It's a program from Autodesk that's written specifically for FRC. Personally, I don't love it, but it definitely works. We are actually looking at a few other options for that right now, especially because this year it's something that probably matters more because a lot of the programming will have to be done without a robot.
Remote, yep. No, good point. Thanks for sharing it.
So at that point, I would like to share with the people in the meeting, Henry's done a great job this year of setting up programming meetings and probably bringing in people that may or may not have been interested in programming. But I think just the nature of what we have to go through with COVID and remote learning, it actually could be very conducive for programming learning since you can't actually have people in a room. I noticed, this is would be my second year mentoring, but last year I noticed that there was, when you're in a room with a bunch of students, there can be some goofing around and there may be limited computers. But with Zoom and remote learning, it could be very conducive to get people who were not interested in programming or wanted to bone up their skills, can be very, very productive, I think. So great job in that, Henry.
Thank you.
On that note, Henry, have you added any use of unit testing to the programming training? I know we're only a little ways in right now, but do you anticipate, having some pre-written unit tests?
Right now we're a week in, so I don't think it's the right time yet. But yeah, I anticipate we're definitely going to talk about unit tests.
All right. Are you going to utilize unit testing, like a unit test that you wrote, as a way to help people get feedback on whether their code is reasonable for solving the problem at hand? Or
yeah.
Anything like
This
that?
kind of comes back to what I was talking about earlier, how unit tests can be work as like a teaching tool, and then eventually, so like the more experienced programmer writes the unit test, and then a less experienced programmer can write code to satisfy those unit tests, and then later you train the less experienced programmer to both write the unit test and write the code. So yeah, I'll probably use that.
In build season, do you guys get around to writing unit tests that much? And do you guys in build season, do you usually stick to this test first development, or does that kind of fall apart?
It definitely falls apart to some extent. I would say it doesn't completely fall apart, and getting that to fall apart less and less as we go is definitely a goal. But yeah, you definitely can't do everything like ideally that you would want to do in build season, but moving closer and closer to that is a large goal for us.
Yeah, because a lot of our like practices go out the window during build season. So
yeah.
Yeah. One thing to remember here is, you know, the idea of the unit, the testing driven development, right, of writing the test first and then writing the actual code is nice, but it's still useful to write the unit tests after the fact, because you don't write your code once and be done with it, right? You tweak it, you change it, especially when you get to competition, right? And you're going on hour 9 of you know, competition for the day, and you're tweaking the code yet again to fix something that didn't go right. Having that unit test to grab the little errors that you made or the problems that you had can save you from having a disastrous match.
Yeah. So like kind of what Jason's saying is that like unit tests, you may forget about them, but then they'll pop back up if you eventually build something that breaks something that you previously wrote. So it can be really useful to just not have to test everything on the robot 500 times before it works.
Yeah, or if nothing else, help you find where that issue was very quickly, right? So that way you're not going, oh, it failed overall. Now I need to comb through, you know, layers of classes and methods and functions to determine where the issue was. The unit test will help me narrow in on specifically where the issue is, and then I can correct that.
Any other questions?
I'll just say this was a really well put together presentation. You've obviously got a handle of not only how to do it, but why and the methods you should be using for you know, unit testing. So well done.
Thank you.
thank you. This was definitely a very well put together talk. I learned a lot. You know, the why and the how. It was technical as well as, you know, more on the holistic side. So you covered it really well. Thanks.
Thank you.
Yeah, like Henry said, the presentation is on our website. So it'll stay there. Feel free to go grab it. Take a look. If you have questions, there's a contact us page on the website, so you can get a hold of us, and we'll try and answer any questions or talk through anything too. Or, you know, if you come up with, you do a good job with writing unit testing or figure out a good way to get people to do unit testing, we'd love to hear about that, because we're by no means perfect on our end. So you know, it goes both ways. Bring us your improvements and ideas, and we'll share out what we have too.